All right, welcome. We're going to be creating our first Visual Studio C++ project in this video. And I want to begin with kind of a few things. One of the main thing is when you're working as a programmer, one of the main things is that you're now a developer. So when you're creating files and naming things, don't have any spaces in them. It's just you just don't do it. So try to get in that habit. So when you're creating a new project, one thing that you always want to do is you want to put it on your desktop so you don't hide it from yourself, so you can actually get into your folder and work with your files, because you're going to be needing to open files for input and stuff like that, and having quick access to your folder where you can put these files and be able to edit them and add to your project is pretty important. So when you go into your create project portion, hopefully it doesn't take as long as it evidently is taking for me right now. But what we're going to be doing is we're going to be choosing an empty project. I'm going to go ahead and pause and wait for this to load up, and then I'll once this screen pops up, we'll continue. Okay, so we have our window that pops up with our Visual Studio. Now, if you're using Xcode, just simply search for Xcode C++ create project or create console project. So what we're doing is we're working with terminal applications. In fact, everything starts with terminal, which is going to be what we call standard input and standard output. It's also a library in C++ called stdin and stdi out. So when you're working with a console app, you're essentially working in your command line, or if you're in like Mac, your terminal, or Unix, your terminal. But you don't have to actually start the executable from here. We can do the executable, start the executable by double clicking it in the window, or we can hit the play button within Visual Studio and it will run our executable for us. So what we're going to want is we're going to want to go up to these windows and make sure that we choose our C++. We're going to want a Windows application, and we're going to want to go with it as a console. And the thing that we're going to want is we're going to want an empty project. So remember, no names. You might want to give some thought on what your project is actually doing. Use a descriptive name. Use underscore instead of spaces. So this would be my first project. That's using underscores. The other way you can do it is Camelback. That's another good way of doing it. Now notice I put them in the location on the desktop here. We also want to make sure that the solution and the project in the same directory. Now, a project basically just contains your C++ files, which is your code, which is your actual application. Your solution can contain multiple projects, which would be multiple different executables or precompiled libraries or whatnot. So you know, this one is not specifically needed. I just kind of like to do it. Sometimes I forget, but for you, project, don't worry about this word solution. Just worry about the idea of a project. And a project is a series of CPP files that create an application. And what you're going to be doing is you're just going to be having one CPP file for now, which is C++ file. So this is the project. It's not the code. So this is going to contain the code that we add to the project for our executable. So I'm going to go ahead and create that on the desktop with the name of my first project using Camelback. And it's going to pop up here. And what I'm going to do is save all. And if we look at this project, it doesn't have any source files over here in the Solution Explorer. This is what shows all our C++ files and our header files, everything that makes up our solution, which is our project. So I said your solution, you can have multiple projects. We're only worried about just the project. We're not going to have any more than one project. You probably will not have that for quite a while. The project is where we want to add our CPP file. Now we could do this two different ways. We could add our CPP file as just a straight up text file, and that text file we can add into the folder that I saved. So I want to make sure everything's updated, so I'm going to do a save all here now that I've created the project. And then I'm going to go into the folder of my first project, and this is what's built for us. Now you see this is the solution file. You can open up your project and close it by double clicking on the solution file or the project file. And this does not contain the code. It contains just information about your project, what type of project it is, what the executable builds as, etc. So we're going to add code to this project that's going to build compile our code for us. So I'm going to go ahead and open that up. You can do it with one or the other. When you send code, you're not going to be sending the SLN file. I get that a lot. But you can double click on one or the other to open up your project again. And what we're going to do is you can add right here. You can go in here and you can say new, and you can say text document and name it as a .cpp, and then add it to the project. Make sure you do it in the same folder as your project is, or you can go here to project, add new item. You can also right click over here and say add new item, and this is where we're going to actually add the header file, not the header file, excuse me, our source file, which is going to actually contain our main. Some people just keep this as called source. I like to just call it main because that's when our main function is, and our main function is essentially where our program starts. So with anything within that main function, which is denoted by a pair of braces, is our program. So I'm going to go ahead and choose main.cpp as my project file. And now that file has been added to my project, and now I can actually add some code to it and do some, actually write the code that I need. So I'm going to include some libraries, which are prepackaged code for us to use. IOStream contains the standard input and standard output libraries, stdin and stdout, which allows us to do what we call a cout and a cin, not sen and cout, cout and cin, which allows us to do input and output to and from the user, using that standard input and output, which every programming language uses. It doesn't matter what it is. So that IOStream basically means input output stream. And then this using namespace std, what that is you want to use the standard namespace. So basically the variables that are inside of this library called input output stream are protected by a container called the standard namespace, and that's because you don't want your variable names to clash with variable names that you create of libraries that you use, meaning code that's pre-prepared for you, such as cout and cin, and other libraries that you would use as tools. So that's what that namespace idea is basically to protect libraries or U from the variable name variables inside of other libraries. Because if you were to name a variable that is the same as something in a library, we used to have all kinds of problems where that would cause all kinds of weird, funky bugs. And that's another reason why tech support says, did you restart it yet? So here's going to be our main, C DOS style is void, Unix, Linux style is int, return, and then you have nothing that you're going to actually take as an argument. Incidentally, you might want to look into argc, argv. Here, argc, argv are how you set up so that you can pass arguments. It's essentially how the whole Unix and Linux system works. It's kind of funny, but that's an interesting thing that you want to look into probably. Now, one thing that we need to add down here, since we're using DOS, is a system pause. And basically, it's just like we're in the terminal and we type in pause. And what it does is it stops the window from closing on us when we run our code and we do some output. So this is kind of the main thing. Actually, we don't really need this. I'm going to go ahead and comment that out, so it's not going to be compiled. That's what this is just a comment. So what I'm going to do is I'm going to go up here and I'm going to build, rebuild solution. And what that's going to do is it's going to allow me to get in here and see how the compilation of the code happened. And you can go in here, down here in this output window, and you see here that in my folder, my first project, and a debug folder was created, and there's my executable, my first project.exe. So if I go over here to my first project, all of a sudden I got this debug window, and I can go in there, I can run my program by double clicking on this exe, and since my program kind of does nothing, it basically does nothing. So if I put in this like system pause, it'll probably show the window. But the program just starts up and basically doesn't even show a window because it does nothing. There's no input or output yet. The system pause will tell it to wait for some input from us before closing the window. It just runs so fast that we can't see it. So I'm going to do rebuild again, and I'm going to run it. And it should work, unless there we go. Okay, so and then so that system pause is just that pressing a key to continue, and the program ends. So this is the brace, the start of your program, close of the brace, the end of your program. Here's the function that denotes your program, and main is just a function that you can pass arguments to, and you'll be learning about functions as you as you progress. So we're going to do a cout, hello world, and this is going to be your traditional new language beginning application. Now for your assignments, you're just going to choose 2 already done programs from your chapter. Now here's one thing that's crucial. When you do your next chapter assignment, you're going to choose 4 programming assignments from the back of the chapter's programming assignments challenge. They're challenges at the end of each chapter. That's kind of your main work, and that's what you're going to be using to gauge your success. Choose ones that make sense for you, but also challenge yourself. If you choose 2 of the lower digits and 2 of the higher digits, that's the double digits exercises from the book, you do that for every chapter after you do your chapter reading, you're going to be doing pretty good. This is getting started, and one other thing that I'm going to want from you is screenshots. So I want the code. I don't want the code as a screenshot. The only thing I want a screenshot is this black window. The code you got to actually take and copy and paste as text. You take it, you copy it, you open up Windows document, and you paste your code. Make sure you label it up here. Label what it is. That means the programming assignment. or the programming number that it is from the back of your book, back of your chapter. It's going to be at the back of your chapter. I've had students that have made that mistake before. So, and that's only for your second assignment, not your first. Your first assignment is just getting the compiler working, whether it's Xcode or Visual Studio. So you get your label in there, put your code in, and then you go in here and you do a screenshot. Now you can do a snipping tool. So you can snip. You can do a new snip and just choose the window that I want, and that'll copy onto the clipboard. Usually I just do Control C here just in case, but it usually should be on the clipboard, and you can just paste it here, and then that would be for one problem. So you get your code and your output, and then that would be for one problem of your assignment, and then you would put your next problem down here and then turn that in as a document. And that's kind of how you would do everything and get started. Now make sure you view your assignments portion in Canvas. That's going to give you all your weights of the course, so that you know kind of the percentages of everything. I believe a 95% is like, if I remember right, it's either 95 or 96. It's a 4.0, and it drops down 0.1 from there. But you can check the syllabus to make sure on that. It's the CBC standard grading scheme, so no, it's a CBC standard. So, all right, that's it. Thank you.